Hello, my name is Garrett Hinton, and this is Physics Lab 1, Continuous Motion for Physics 2211. Getting started, we have a table of contents, and through this presentation there will be an introduction, assumptions, computational model, observations, comparisons, glow script, code, and then a final concluding what if slide. So for introduction, um, basically, the purpose of this lab is to observe and to model the motion of some object that is moving at the same speed without changing in direction. So in performing this lab, I rolled an object. In my case, I used an orange. Tracked the motion of the object in Tracker. I simulated the motion in GlowScript, and then I compared the motion of the object and the model um, against each other. Here are some assumptions and principles. I was using Newton's second law. An object in motion will stay in motion unless acted upon by an outside force. I assumed in my computational model that friction is negligible. Net force equals 0 newtons in an ideal model. I also use a momentum principle. Final velocity equals initial velocity plus net force over mass times delta t, and then the position update formula as seen here. And then here some brief overview of some of the results of my computational model, as you can see here, or no, excuse me, of my tracker. So at t equals 2.867, the position of the graph is, or the x position is 1.748 meters away from the origin. Here is the video. The system is the orange, and the surroundings are the floor of my hand, etc. And here is the computational model, beginning around here, shown in the graphs, and as it's an ideal model, it has a straight line graph for position and then constant velocity, as shown in the graphs. Here's my glow script code. As you can see, the mass is 0.267 kilograms with a starting velocity of 1.576 in the x direction. Initial position at the origin, starting at time equals 1.33 due to just when the video started. And then we have the step size, and then the other initial conditions and physics models and equations that are used for the lab. In my observations, you can see how I tracked the orange, and then the graphs here are definitely not the straight line that you saw in the computational model. They're more varied, and then the results are not necessarily linear as the orange is moving. Comparison. The actual final velocity is less than the computational model. This is because the orange was initially accelerated by my hand, but then was acted upon by friction and slowed down. And then error in this case, friction was not accounted for, but tracking was not as precise as it could possibly have been. These are possible explanations for why the proposed final velocity and the actual final velocity are not the same. And then some what if questions. If the positive x and the negative x were interchanged, this is like a change in direction, changing sign based on like where the orange is thrown. So possible changes, the initial and final position or direction of motion could have been changed. And then what about net force and friction? So gravity versus normal force is they cancel each other out as the orange goes, and then friction is applied to the actual orange. And yeah, thank you. That's it.